Alright, we're talking about interior and exterior angles of polygons today. First, a polygon is a closed figure formed by segments called sides that intersect with other sides at their endpoints called vertices. So notice here's a couple examples of polygons. Each one of the sides is a line segment. That means they are straight. They're not curved like this one. That's why this one is not a polygon. And they intersect each other at their vertices. They intersect at the endpoints of those segments. This is not a polygon because these segments are intersecting each other at points that are not the endpoints of those segments. Okay, so these two are polygons, these two are not polygons. Okay. There are different types of polygons. Polygons can be separated into convex and concave. For convex, if you could try to connect one vertex to another, that line segment will always go through the interior of the figure. If I try to connect these two vertices, that line segment will go through the interior of the figure because it's convex. When it's concave, while some of them, when connected, will go through the interior of the figure, there will be at least one place where if you connect two vertices together, that line segment would be on the exterior of the figure. So that makes this one concave. A less formal way of talking about it is it looks like some of the sides have caved in on the figure. We classify polygons by the number of sides. So if a polygon has 3 sides, it's a triangle, 4 sides, it's a quadrilateral, and so forth. It'd be good for you to have these memorized, but not completely necessary. You can always have this to refer to. When we do our quizzes and tests, you can write it in your notes if you need to. One thing I do want to point out is when it doesn't fit one of these categories, if it doesn't fit one of these already classified, we can just call it an n-gon based on whatever the number n is, n being a variable. So if it has 14 sides, we can call it a 14-gon. If it has 27 sides, we can call it a 27-gon. Alright. The sum of the measures of the interior angles of a convex polygon with n sides is 180 times n minus 2. So, for example, on this polygon right here, this polygon has 5 sides, and it has 5 interior angles. The sum of these angles, if I had took all these angles and added them together, we can find that number by using this formula to find out what they add up to, where n represents the number of sides. Okay? So on example 1, it says find the sum of the interior angles of a decagon. Okay, well, you might remember that a decagon has 10 sides. Well, that means that n is going to be 10. So when I take this formula, I substitute 10 in place of n, and we find out what we get. So do what's in the parentheses first. 10 minus 2 is 8, and 180 times 8 is 1,440. So the angles inside of that decagon, all the interior angles, will have a sum of 1,440. Okay? A regular polygon is a polygon that is both equilateral and equiangular. Most of the polygons that you're used to seeing through elementary school when you were first learning these were regular polygons. For example, a stop sign is a regular octagon. All the sides are congruent, all the angles are congruent. A yield sign is a regular triangle. All the sides are congruent, all the angles are congruent. Okay? The measure of each interior angle of a regular polygon, has to be a regular polygon, with n sides is 180 times n minus 2 divided by n. Okay? Now remember, this 180 times n minus 2, that was our formula for the sum of the interior angles. So we are now taking the sum of the interior angles and dividing by the number of sides. The reason we do that is in every polygon, the number of sides is the same as the number of angles. So just think about a triangle. A triangle has 3 sides. It also has 3 angles. Think about a square. It has 4 sides. It also has 4 angles. Okay, a decagon has 10 sides, it has 10 angles, and so forth. So while n is representing the number of sides, it's the same number, and so we can use it as the number of angles as well. So we take the sum of the interior angles, and we divide by the number of angles, and that tells us the measure of each angle. Now that only works when it's a regular polygon, meaning that all the angles will be the same measure. So let's look at example 4. It says find the measure of each of the interior angles of a regular convex 20gon. So I'm going to take that formula and we're going to substitute the number of sides in here. Since it's a 20gon, n is 20. And there's our formula. All we have to do is work that out and find out what it gives us. Just simplify it down. So 20 minus 2 is 18. 180 times 18 is 3,240. And 3,240 divided by 20 equals 162. So on any regular 20gon, the measure of each interior angle would be 162 degrees. Okay. If the measure of an interior angle of a regular polygon is 150 degrees, find the number of sides in the polygon. Okay, remember this was our formula to find the measure of each interior angle of a regular polygon. So if they tell us the measure of a interior angle of a regular polygon is 150 degrees, that means that this formula should give us 150. It should equal 150. And then our goal is to find the number of sides in the polygon. Well, n represents the number of sides. So we have an equation now, and we want to solve for n. Okay? The first thing I'm going to do is distribute to get rid of these parentheses. So 180 times n and 180 times negative 2. And then just rewrite the rest of the equation. Okay, the next thing I want to do is I do not want the variable in the denominator, so I want to get rid of that. When things are being divided by n and you want to get rid of it, you need to do the opposite operation. Opposite of dividing is to multiply, so we're going to multiply by n. If this is multiplied and divided by the same number, those opposite operations will cancel each other out. Now if I do something on one side of the equation, I have to make sure to do the same thing on the other side of the equation. So I have 150 times n, which is just 150n. Okay, I don't want n on both sides. We need n in one place, so I got to get rid of one of these. I'm going to subtract 150n to get rid of it on that side. And I'm going to continue my equation over here. 180n minus 150n is 30n. Bring down the minus 360. And on the other side of the equation, 150n minus 150n is 0. Alright, we got n in one place. Now we need to get it all by itself. So we got to get rid of the constant first. It's being subtracted, so we make sure to do the opposite operation. So we add 360. 0 plus 360 is 360. And then n is being multiplied by 30, so we do the opposite operation and we divide by 30. And 360 divided by 30 is 12. So this polygon has 12 sides, which makes it a dodecagon. Alright, example 7. Number of sides, 1, 2, 3, 4, 5, 6. 6 sides, which means it's a hexagon. Okay, we are given all of these angles and we want to find the missing angle. We want to find this one right here. Well, to do that, I need to first find out what all the angles should add up to. So remember, for the sum of the interior angles, this was our formula, where n represents the number of sides. We just said the number of sides was 6. So we'll substitute a 6 in for n. 6 minus 2 is 4. 180 times 4 is 720. So I know that all of these angles should add up to 720 degrees. Well, what do the ones I currently have add up to? I got 130, 130, 90, 130, and 120. If I add those all up, I get 600 degrees. So if all of these angles are supposed to add up to 720, and these add up to 600, what is this? Well, I'm going to subtract, find out what's left. That angle has to be 120 degrees. Okay. We're going to do the same basic thing on example 8, except we're going to have to be a little more formal in setting up the equation. We do still start with the same formula. We're finding the measure of each angle. This is the formula for the sum of the interior angles. 1, 2, 3, 4, 5, 6, 7, 8 sides. So we substitute 8 in for n. 8 minus 2 is 6. And 180 times 6 is 1,080. So I know that all of these angles should add up to 1,080. So now I'm going to set up my equation exactly like that. If I know that all these angles add up to 1,080, I'm going to add them all up, set it equal to 1,080. Now you don't have to write this out the long way if you don't want to right off the bat. If you are able to combine like terms in your head, you can skip writing it out the long way. But if I add all of these angles up, that should equal 1,080. Now if you didn't combine like terms right off the bat and you did it the way I just did it, then the next step would be to combine like terms. You have 20 and 20, which is 40. And then how many x's do we have? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 x's. So when we combine like terms, we should have 8x plus 40. So we're solving for x. I got to get rid of the 40. It's being added, so we do the opposite operation and we subtract. And then we want to get rid of the 8. X is being multiplied by 8, so we do the opposite and we divide by 8. And 1,040 divided by 8 is 130. Now, the question didn't ask for x, it said find the measure of each angle. Well, this is x, and x is 130, so this angle is 130 degrees. This angle is 130, this is 130, 130, 130, 130. For this angle, x is 130 plus 20 more. This angle is 150 degrees. Same thing here, 130 plus 20, 150. So you should have 6 angles that are 130 degrees and 2 angles that are 150 degrees. Okay, that's interior angles. Let's talk about the exterior angles. An exterior angle is an angle formed by a side of a polygon and the extension of an adjacent side. So right here, this is an exterior angle, and it's formed by one side of the triangle here, in this case. And when we extend the adjacent side, that extension with the other side creates that exterior angle. So for each of the following polygons, draw all of its exterior angles. If I take this side and extend it in one direction, not both, but just one direction, it creates an exterior angle. I'm going to do the same thing with the next side. I'm just going to extend it, and that creates another exterior angle. I'm going to extend this side. That creates another exterior angle. And extend this side, and again, we get another exterior angle. We can do the same thing over here. Just keep extending each side to create a new exterior angle. How does the number of exterior angles compare to the number of sides of the polygons? Well, just like the interior angles, you should have the same number of exterior angles as sides. So notice this had 4 sides, we have 4 exterior angles. This one had 6 sides, we have 6 exterior angles. So you should have the same number of exterior angles as you have number of sides. Okay, when we did the sum of the interior angles, it was 180 times n minus 2. So it changed depending on the number of sides for that polygon. It's not the same with exterior angles. For exterior angles, the sum is always 360. It does not matter which type of polygon it is. The exterior angles always add up to 360. So when it says find the sum of the measures of the exterior angles of the polygon described in example 2, I don't even have to look back at example 2 to see what type of polygon it is. If it asked me for the sum of the measures of the exterior angles of any polygon, I know the answer is 360 degrees. Okay, since the exterior angles always add up to 360, if I want to find the measure of each exterior angle of a regular polygon, this only works when all the angles are congruent, I can take that sum of 360 and divide by the number of exterior angles, and that will give me the measure of each angle. Now remember, n represents number of sides, but we also learned that the number of exterior angles is the same as the number of sides. So we can use that because it's the same number. So on number 5, find the measure of one exterior angle of the decagon described in example 2. In example 2, it was a regular decagon. So I'm taking this formula, and a decagon has 10 sides, so we're substituting 10 in for n. 360 divided by 10, each exterior angle of that decagon will be 36 degrees. Alright, let's look at example 6. Given a regular nonagon, regular, so all the sides are congruent, all the angles are congruent, nonagon has 9 sides. We want to find the sum of the interior angles. Remember, the formula for the sum of the interior angles is right here. If it's a nonagon, we have 9 sides, so n is 9. So 9 minus 2 is 7. And 180 times 7 is 1,260. So the sum of the interior angles would be 1,260 degrees. Then the measure of each interior angle, well, if all the angles add up to 1,260, and it's a nonagon, so there was 9 sides, which means there's also 9 angles, and all those angles are congruent because it's regular, I can take what all the angles add up to, divide by the number of angles, and that will give me the measure of each individual angle. So there are 9 angles, each one is 140 degrees, so that they can add up to 1,260. Okay, for that same figure, that same nonagon, what's the sum of the exterior angles? Remember, the sum of the exterior angles is always 360. It's not going to ever change no matter which polygon you're talking about. The measure of each exterior angle, well, they add up to 360. How many angles are there? 9. 9 sides, 9 interior angles, 9 exterior angles. And since it's regular, all the angles are congruent. So take the sum, divide by the number of angles, it'll give you the measure of each angle. Each exterior angle is going to be 40 degrees. Alright, we're going to skip example 7. Example 8 is already filled out, but I want to go ahead and explain it to you. It says the measure of an exterior angle of a regular polygon is 30 degrees. So remember, this is our formula to find the measure of each exterior angle. So if we know that angle is 30 degrees, then we know that 360 divided by n has to be equal to 30. Well, now, if we want to solve for n to get the number of sides, don't want to have n in the denominator, so I'm going to multiply by n to get rid of it. If I do that on one side, I have to do the same thing on the other side of the equation. So that gives me 30n is equal to 360. And then to solve for n, it's being multiplied by 30. We want to get rid of the 30. We do the opposite operation, and we divide by 30. And you get n is 12. Okay, we're going to skip example 9, and example 10 is review. We've done this before. Notice we have 2 interior angles of the triangle, but we don't have this one. And this is an exterior angle. One of the sides has been extended, and it creates that exterior angle out here. Remember, we learned a long time ago that on a triangle, the exterior angle is equal to the sum of the 2 remote interior angles. So the exterior angle is equal to the sum of these 2. Remember, sum means add. So I'm going to add those 2 angles together. And from here, it's just solving the equation. So we're going to combine like terms on the right side of the equation. We got 3x and 2x is 5x's. We got 8 and 1 is 9. Okay, now we don't want x on both sides of the equation, so I'm going to get rid of one. So I subtract x, and that gets rid of it on that side. Then we want to get x all by itself. I'm going to get rid of the 9. It was being added, so we do the opposite, and we subtract it. And we want to get rid of the 4. X is being multiplied by 4, so we divide by 4. And that will give you the answer for x.